Question 14, Part B. So Part B says, name the product formed at each electrode. Now it hasn't actually labelled the electrodes, but we should know that during electrolysis we're going to have a positive and a negative electrode. The thing to remember here is that during electrolysis, opposites attract, so our negative ions, in this case that's iodine because that's the non-metal, are going to be attracted to the positive electrode, whereas the positive ions, in this case the cadmium, because it's a metal, are going to be attracted to the negative electrode. So at the positive electrode it will be iodine that's formed, and at the negative electrode it will be the cadmium that's formed. Okay, part C is a bit more of a problem-solving question. It says, give a possible reason for the faulty results at the end of the experiment in Table 1. So in Table 1, the bulb stays lit even when the apparatus has cooled. Now, a few of you suggested that that might be because the apparatus hasn't fully cooled and the cadmium iodide is still molten. I think that's a fair enough suggestion. One thing to pay attention to though is any extra information that you're given in the question, because often this gives you a clue to what some of the answers might be. So in this question it tells you specifically that it's a nickel crucible that they're using. Now there's not really any other reason for them to give you that information. If you know your periodic table, you should know that nickel is a metal. What jumped out at me when I saw this question was that it's possible that these electrodes could have ended up touching the nickel crucible. So that's one other explanation for what could have happened in the experiment. Another possibility would be remembering the clue given to us in question B, that cadmium is formed at one of the electrodes. We could have had a situation where the cadmium formed, which is also a metal, ended up somehow connecting the two electrodes. So that's the two other possible explanations.